Hello. So today we're going to be looking at simplifying some surds, in particular some bracketed expressions with surds, and then we're going to be moving on to rationalizing the denominator for some simple fractions that have just got a single surd on the bottom. We're going to start by looking at reminding ourselves of how surds work and how we can manipulate them, how they are similar to algebraic terms and how they act like algebraic expressions in some cases, and also just to remind you of some of the common pitfalls that you might you will want to avoid. So starting here, we've got the square root of 5 multiplied by the square root of 2. So when I'm multiplying a pair of surds together, I often try and think of these as being just like algebraic operators. So if I've got, like, say, x times y, we would write it as xy. However, surds have got this added function that they can, when you multiply them together, the numbers can combine so long as you're multiplying a surd by a surd. So for example here, square root of 5 times by the square root of 2 is exactly the same as the square root of 5 times by 2, which is the square root of 10. So this multiplication here can come underneath the entire surd, and you can multiply 5 by 2 together to get 10 underneath the surd, which is very useful, and hopefully you've been using that a lot in the work that you were doing before the Easter break. Looking at this one though, this is one of these pitfalls that I was talking about. Here I've got 3 multiplied by root 5. A lot of people would write square root of 15 because they say 3 times 5 and they think, oh, that's going to put 15 underneath. But here these are two different things. So this one here is a surd. It's what's called an irrational number because it can't be written as a fraction. It's 2.7 something, I think. Whereas 3 here, this is a whole number. This is what's called an integer. It's a rational number. Okay, so you can't multiply these two things together and get a nice simplified format because of the fact that these two numbers are currently, one's in surd form and one is not. Now I can kind of force this one to be in surd form by writing it as the square root of 9, and then we can combine them if we wish. But at this point here, we're just looking at being able to simplify things. So if I've got 3 times by, say, let's call this y, so 3 times by y we'd say was 3y. So 3 times by root 5 we're going to say is 3 square root of 5. In the same way that you treat algebra by removing multiplication signs that are needless, you can do the same thing here. You're going to remove any multiplication signs that are needless because we have that common framework, the common language that mathematicians use. We don't need to put a multiplication sign in there because we know that there is one there. The next one here, we've got simplified square root of 18. Now this is a technique that we looked at in the last video. I showed you a couple of ways of doing this. My particular favourite way is the idea of prime factorisation. So I'm going to write 18 down and prime factorise it, and then I'm going to look for pairs. So I'm going to do that over here. So I'm going to write 18 just there, and then we're going to do our prime factor tree. So I can split into a 9 and a 2, and then I can split the 9 into a 3 and a 3. Okay, just like that. So what I'm looking for here is I'm looking for pairs. So hopefully you can see that I've got a pair of 3s there. That means that this pair of 3s can be square rooted because this is 3 times 3 and the square root of 3 times 3 is just 3. So here the square root of 18 I can write as a 3 on the outside of the surd because this is the part of this number 18 that I can square root. What's left here, I've got a single 2 that's left and I can't square root that 2, so that lives underneath the surd. It can't be simplified, can't be brought out side the surd. So the pairs, you cross them out and you just bring one of them outside because the square root of 3 times 3 is just 3, and then the 2 stays inside the surd because I can't square root it. So we're going to put those things into practice when it comes to expanding and simplifying. Now hopefully you'll remember that from last time we looked at some examples of expanding and simplifying where I have a single bracket. Today we're going to have a look at double brackets, and then we're going to move on to this idea of rationalizing the denominator. So as a reminder from last time, when you're multiplying brackets out, what you want to be doing here is you want to be looking at multiplying everything that's outside the bracket by everything inside the bracket. So here the square root of 3 multiplies by the square root of 6, and also the square root of 3 multiplies by the negative square root of 3 there. So here square root of 3 times by square root of 6 is square root of 18. So thinking back to that first reminder that I showed you, if I multiply two surds together, you can multiply the numbers together and that goes under the surd. Same thing here, square root of 3 times by the negative square root of 3, it's going to be a negative, so square root of 3 times square root of 3 here is square root of 9. Now both of these things we can simplify. This one here, square root of 18 we simplified before, and we got 3 root 2. And the square root of 9, we know what the square root of 9 is, that is simply just 3. Now the common mistake that people would make here is they'd say, right, well, square root of 18, if I take away 9, that's going to give me just square root of 9, so they do 18 take away 9, because they say, well, I can multiply these two things together and it works, so surely subtraction works as well. Unfortunately it doesn't. You can't subtract square root of 9 from square root of 18 and just get square root of 9, because then this entire expression would turn out to just be the square root of 9, which would be 3, and this isn't what we get. We would be missing most of this expression here. And you can again type this kind of thing into your calculator and verify that this simplifies down to 3 square root of 3 subtract 3. The next one, where you're multiplying out a pair of double brackets. If I'm multiplying out a pair of double brackets, you need to work in exactly the same way as if you were multiplying out double brackets with algebra in them. So you multiply everything by everything else. Now there are a couple of different ways of doing this. Some people use the acronym FOIL. So I'm going to write that there. FOIL, first, outer, inner, last. So they multiply the first two together, they multiply the outer two together, they multiply the inner two together, and then they multiply the last two together. So the first two terms, the outer two terms, they're the ones at the edge, the inner two terms, they're the ones on the inside, and then the last two terms, that's these two. And once you've multiplied all those things together, you have got them. Now I'm going to run through a couple of different sort of ways of thinking with these. I'm actually going to get a piece of scrap paper and show you the way I would do this. But I know that most of you guys in the group do it with arrows anyway, so just as a reminder of this, and then I'll keep peddling my method. So here, square root of 2 times by 2 is 2 square root of 2. Square root of 2 multiplied by the square root of 2, it's the negative square root of 2, so it's going to be negative. It'll be square root of 4. Next one, so that's your first, your outer, now you've got to do the inner, so 3 times 2 is 6, it's positive 3 times by positive 2, so it's a positive 6. 3 times by negative root 2, so it's going to be a negative. 3 times root 2 is 3 root 2. And then this one here can be simplified down. We know here that the square root of 4 is just 2. So that term there is actually just minus 2. So we've got 2 square root of 2, take away 3 square root of 2. So that's like having, say, if I had 2x, take away 3x, I'd end up with negative x. 2 of something, take away 3 lots of something, I end up with negative 1 lot of that thing. So here I'm going to end up with negative 1 lot of square root of 2. I don't need to write a 1 in front in the same way that I wouldn't need to write a 1 in front of x. If I had a single x, I'd write x. I wouldn't write 1x. So you do the same thing here with surds. And I've got negative 2, add 6, which is positive 4. Now I know that some of you will prefer to write this as 4 subtract square root of 2, using that fact that addition here is commutative, so I can swap the 4 and the negative root 2 around and have 4 at the front and negative root 2 at the end. Either of these will get you full marks in the exam. You don't have to write it like that. I prefer to write it like that myself, and I know that some of you are pedants like I am, and you would prefer to write it like that as well. Another way of doing the expanding a pair of double brackets, if you're not using arrows, is the way that I prefer, which is using a grid method. Now I know that a lot of you in the group aren't keen on the grid method, and that is because of the fact that you say it takes time and effort and so on and so on. I prefer this because it stops you getting things wrong. When you're doing the arrows, FOIL is fine and well if I've got 2 things in the first bracket and 2 things in the second bracket, but that's not always going to be the case. I might have, say, 3 things in the first bracket and 2 things in the second, in which case FOIL doesn't work, and you've got to make sure then you've got all your arrows. Now you might be happy with that, and that's fine, but you might miss some terms, and that's the common mistake I often see when I'm marking papers, that people miss terms out, and when they miss terms out, they lose marks. If you draw a grid, you've got a box for each or a place within the grid rather for each multiplication that you're doing, and so it's pretty hard to miss a term out. You might make an arithmetic error, but the same way that you could make an arithmetic error here when you're multiplying. So what I would do personally is I would draw myself out a little grid. It's a multiplication grid, and I'm going to write one of the brackets down one side and one of the brackets across the other side. Now in this particular setup, because I'm doing multiplication, it doesn't matter which way around I put it. I could put root 3 plus 2 across the top, I could put root 3 plus 2 down the side. It doesn't matter which one goes on which side, because multiplication is commutative. That means you can do it either way around. 2 times 5 is 10, 5 times 2 is 10, you get the same result irrespective of which way around you do the multiplication. So here we're going to put square root of 3 plus 2 across the top. I'm going to put square root of 2 plus 1 down the side. Again, like I say, if you want to swap those around and just check to see if you get the same answer as me, then that's fine. Square root of 2 times by the square root of 3 is the square root of 6. 2 times 3 is 6. Square root of 2 times by 2, if it was x times 2, it would be 2x. So square root of 2 times 2 is going to be 2 lots of root 2. It's 2 lots of this irrational number, 2 root 2. 1 times square root of 3 is 1 lot of the square root of 3. Just write root 3. And then 1 times 2 is 2. Now, looking here, a lot of people would say, right, well, I need to tidy things up like we did here. So here we had a square root of 4 which simplified. Brilliant. Are there any square roots that simplify here? Well, these two don't because they're prime. This one doesn't. If I think about what 6 simplifies, 6 breaks down to, if I write 6 there, break it down to its prime factors, it's 3 and 2, so there are no pairs. So the square root of 6 doesn't simplify any further either. So what that means is that I can't combine any of these together in any kind of meaningful way. Imagine this is like 2x, y, z, and a 2. So you couldn't combine the x, y, and z if you were in that sort of situation, and it's the same thing here. You can't combine the square root of 2, square root of 3, and the square root of 6 together either. So we've got, and I'm going to write this as 2 square root of 2 plus the square root of 3 plus the square root of 6 plus 2. Now the order that you write that doesn't really matter. I don't particularly think there's any kind of conventional way in writing surds. I've just written them here going up in numerical order in terms of the surds, so 2, 3, 6. But any order that you put that in, so long as any negatives that are attached to any particular terms stay with them, you'll get full marks. Now on to the second part of this video. It's about rationalizing the denominator. So what we need to do is we need to understand what this phrase here means, and then we can try to understand how we might approach that kind of question when you've got these various different examples. So rationalize the denominator is exactly what it asking you to do, exactly what it says. It wants you to rationalize the denominator. Now there's steeped in vocabulary here, so we need to break this down and understand what we're talking about. The one word here that you will know, I'm not thinking about I'm thinking about the word denominator. So denominator, we know, is the bottom number on the fraction. So here, this is talking about the bottom number on these fractions. So the root 2 here, the root 5 here, the root 3 here, and the root 6 here. So we're wanting to do something with the denominator. We're wanting to do something with this number here. So what is it telling us that we want to do with that? It's telling us we want to rationalize that denominator. So rationalize, you'll recall further up, I talked about rational and irrational numbers. Rational numbers are ones that can be written as a fraction. So things like a half, a third, 3/7, 2 1/4, all those kind of things, and even whole numbers. So 3, that could be written as a fraction, couldn't it? Could be written as 6/2. But whole numbers, fractions, they're all rational numbers. Things like surds, things like pi, and if you know e, the natural number, these things can't be written as fractions. So the square root of 2 cannot be written as a fraction, so it's not a rational number, it's called an irrational number. So what it's asking you to do is to rewrite this fraction using an equivalent fraction where the denominator, so it's the bottom of the fraction, is not an irrational number, so it's not surd. We want to maybe make this a whole number. That would be nice, wouldn't it? We like fractions with whole numbers on the bottom. So that's what we're going to try and do. We're going to try and write this fraction as an equivalent fraction but with a whole number on the bottom. Now in order to do that, what we're going to have to do is we're going to have to manipulate this in the same way that if I had something like, say, a half, and I wanted to make it so that that was 4 on the bottom. This is the kind of question that you may have done way back in like year 6 or year 7. So if I want to write a half as in quarters, what have I done at the bottom? I've doubled it, so I need to do the same to the top. You know this process. I think I've got a circle here and I colour half the circle in. Got another circle here that's split into quarters and I colour 2 of the quarters in. These are the same thing, they're just represented using a different fraction, using a different representation of the whole thing. So here halves is a circle split into halves, here a quarter is it's split into 4 pieces. The actual amount of the circle that's shaded in is exactly the same. So these two fractions are equivalent. We understand this back sort of at a very basic level back from year 7. We're going to use that fact here that I can multiply the top by something and the bottom by something, and if I multiply them by the same thing, so if I times the top by 2 and the bottom by 2, I get the same fraction, it just looks different. So what we want to do is we want to make the bottom rational. So what I'm actually going to do is I'm going to multiply by the square root of 2. Now, you're thinking, well, is it always going to be the square root of 2? No, in this example, it's going to be the square root of 2 because the denominator is the square root of 2. If I multiply the square root of 2 by the square root of 2, I end up with the square root of 4. And we know that the square root of 4 square roots nicely. The square roots to give us 2. But at the moment, I've neglected the top completely. I've got to multiply the top by the same thing. If I multiply the bottom by the square root of 2, I have to multiply the top by the square root of 2. So it becomes 3 square root of 2. Well, does 3 square root of 2 simplify? No, it doesn't. So this here, 3 square root of 2 divided by 2, or 3 square root of 2 over 2, this here is the same fraction as this one, except it's written with the denominator, that's the bottom of the fraction, being a rational number instead of an irrational number. So we're going to do the same thing here now with this one. So we're going to multiply the top and the bottom by the same thing. Here I multiplied by the square root of 2 because the denominator was the square root of 2. So here I'm going to multiply by the square root of 5 because the denominator is the square root of 5. So let's simplify this. 2 square root of 3 times by square root of 5. So that's going to be 2 square root of 15. So 3 times 5 inside the surds can multiply together. The number on the outside can't multiply, it stays on the outside. And on the bottom, square root of 5 times by the square root of 5 is the square root of 25, which is 2 square root of 15 divided by 5. And we're done, because this can't be simplified any further. If you think about 15, the prime factors of 15 are 3 and 5, and there's no pairs there, so that means that square root of 15 can't be simplified any further. So we're all done. On to the next one. I'm going to multiply the top and bottom here by the square root of 6. So multiply by the square root of 6, multiply by the square root of 6, write those down there as a little note to remind me what I'm doing. So 3 times by square root of 2 times by the square root of 6 is going to be 3 on the outside. Inside, these two things here combine, so square root of 12, divided by square root of 6 times by the square root of 6 is square root of 36. Now, I know what some of you will be thinking, do I have to write square root of 36 every time? Can I just know that square root of 6 times square root of 6 is 6? In the same way that you would know that square root of 2 times square root of 2 is 2, square root of 5 times square root of 5 is 5. Absolutely, you don't have to write this in here. I'm only writing it in for completeness to help people understand what's going on and not just think, well, where's that square root gone? Square root of 6 times square root of 6 is the square root of 36, which is 6. Now, before I write the top, we need to consider this 12. So the square root of 12 here, well, let's have a look at 12. So if I break 12 down into being, say, 2 and 6, and then 2 and 3, you might see that I've got a pair here. I've got a pair of 2's, which means I can bring a 2 outside. So I can bring a 2 on the outside, so I've got 3 lots of, and the square root of 12 simplifies down to being a 2 on the outside, and I've still got a 3 that's left on the inside, so 2 square root of 3. So having that, I've got 3 times 2 on the top, so I'm going to have 6 square root of 3 over 6. And hopefully the astute amongst you should recognise that the 6 and the 6 will cancel, leaving us just with the square root of 3 as our final answer. The last example here, so 1 plus the square root of 3, 1 plus the square root of 3 over square root of 3, we need to do the same thing again, so multiplying the top and bottom by the same number. Multiply by the square root of 3, multiply by the square root of 3. Now, when I'm multiplying the top by the square root of 3, I need to multiply everything by the square root of 3. So 1 times by the square root of 3 is the square root of 3. Square root of 3 times by the square root of 3 is the square root of 9. Again, the astute amongst you might just think, oh, that's just a 3, and you'll be right. On the bottom, square root of 3 times square root of 3, square root of 9, again, that's just going to end up being a 3. Simplify this down, so that'll be square root of 3 plus 3 divided by 3. Now, there is a very, very common mistake that people make in the exam when they get to this stage. It happens with algebra, it happens with surds. You end up with something like this, and people look at it and say, right, well, actually, I think that I can just cancel that 3 with that 3, and just leave me with the square root of 3. But we can't do that, because there's addition going on here, and I'm going to show you on a scrap of paper an example of sort of why this doesn't work in general, because it's fine and easy for me to say just as a maths teacher and say, well, you can't cancel those 3's, it doesn't work like that, stop doing it. You need to understand why it doesn't work. So what I'm going to do is I'm going to show you an example of a fraction. So if we went for something like, say, 3/4. Okay, we know 3/4 well, 0.75, 3 out of 4 pieces of a peat shaded in. What I'm actually going to do is I'm going to write that as 1 plus 2 over 2 plus 2. I'm thinking, what are you doing, sir? You're complicating this. Well, 3 is 1 plus 2, sure, and 4 is 2 plus 2. You might be able to see where I'm going with this. If I were to just sort of cancel those out and say that that 3/4 here was the same as a half, you call me an idiot. And you would be right, because 3/4 isn't the same as a half. So you can't cancel this out. This is wrong. You cannot do that. So you can't cancel these 3's out either. And this all comes down to the fact that there is a plus going on here, right? This one, where we had these 6's that cancelled, it's because there's a multiplication between these two terms on the top. This is 6 times by the square root of 3, because as we looked at way back at the start here, multiplication signs between these two items, between these two terms, you don't need to write in, because we have that common mathematical language that we use, that framework where we know that when I've got a rational number next to sort of an algebraic item, that there's a multiplication there. So like 3x we know is 3 times x, 3√5 we know is 3 times by √5. And it's the same thing here at the bottom. So 6 times by √3 divided by 6, well, the 6 is cancelled because there's a multiplication sign between them. There is no multiplication sign between √3 and 3. It's an addition sign, and so you can't cancel them out. So you need to be really careful about falling into that pitfall. Right, that's all for tonight. I'm going to do some more rationalizing the denominator in the next video, except the surds on the bottom won't be single surds. There'll be things like 1 plus √3, but that'll be on the bottom, and we'll have a look at things like difference of two squares and how we can use difference of two squares in order to be able to simplify that. And that's going to be some of the most complicated stuff that you're going to be looking at with surds in the GCSE. Again, as usual, if you've got any questions, drop a comment and I'll get back to you, or send me an email and I'll sort you out. All of this is to go with the work for this week that is currently on SharePoint. Again, like I say, any questions, just hit me up and I'll sort you out.